The moment the Tesla bot Gen 3 finally broke into a sustained 7-mile-per-hour run, it wasn't just another demo milestone. It felt like a line quietly crossed in the history of robotics, because for the first time the movement no longer looked like a lab experiment pretending to be human. It looked like something genuinely alive in motion, something with intent, balance, and momentum that didn't rely on cinematic tricks or selective camera angles. The run was not flashy in the way people expect from viral tech clips. There were no explosions of music or dramatic slow-motion cuts, and that's precisely why it landed so hard. The bot accelerated smoothly, planted its feet with confidence, and maintained speed without wobble, hesitation, or the micro-corrections that usually give humanoid robots away. 7 miles per hour doesn't sound insane until you realize that for a bipedal humanoid robot with a human-scale frame, human-like joints, and real-world power constraints, that speed represents a brutal convergence of balance, perception, motor control, and energy efficiency all working at once without failure. This wasn't a sprint fueled by a hidden support system or a brief burst before collapse. It was a controlled run, and that distinction is everything. What shocked even seasoned engineers wasn't the top speed number itself, but how little drama accompanied it. There was no visible strain in the knees, no exaggerated arm flailing to compensate for instability, no telltale pauses where the system needed to recalculate its next move. The Tesla bot Gen 3 moved like it expected the ground to be there, like it trusted its own mass and timing, and that confidence is the hardest thing to fake in robotics. Elon Musk's reaction reportedly wasn't the loud theatrical surprise people imagine, but a quieter, more unsettling kind of shock. The kind that comes when you realize the roadmap you thought was 5 years long just collapsed into 2. This run wasn't supposed to look this clean yet, and internally forced a re-evaluation of what ready actually means when it comes to deploying humanoid robots outside controlled environments. The real upgrade wasn't speed, it was integration. Gen 3 represents a shift away from modular progress toward holistic performance, where perception, planning, and actuation are no longer treated as separate problems stitched together by software patches. Tesla reworked the entire lower body architecture, not just in terms of stronger actuators, but in how force is distributed through the frame. The ankles, long considered a weak point in humanoid robots, now feature a redesigned torque density profile that allows micro-adjustments at high frequency without burning excessive power. That alone explains why the run looked smooth rather than frantic. The hips, often overbuilt to compensate for poor balance algorithms, were slimmed down and paired with a new predictive gait model that anticipates ground reaction forces before contact is fully made. This means the bot isn't reacting to instability, it's preventing it, and that's a massive leap. Then there's the neural side of the system, which quietly received one of the biggest upgrades Tesla has ever shipped into a physical product. Instead of relying on pre-computed motion libraries or rigid state machines, Gen 3 uses a continuously learning locomotion model trained not just in simulation but through real-world data captured from thousands of micro-runs, slips, recoveries, and imperfect steps. The result is movement that doesn't collapse when conditions deviate slightly from the ideal. During the 7 miles per hour run, subtle changes in foot placement and stride length happened on the fly, not because the bot was correcting a mistake, but because it was optimizing in real time. This is the same philosophy Tesla uses in its vehicle autonomy stack, now transplanted into a body that has to deal with gravity in the most unforgiving way possible. Energy efficiency is where things get truly insane. Earlier generations of humanoid robots could achieve short bursts of speed, but only at the cost of draining batteries at an unsustainable rate or overheating critical components. Gen 3's run didn't just look fast, it looked efficient. Thermal readings showed surprisingly low heat buildup in the knee and hip actuators, suggesting that Tesla's new motor design, combined with advanced regenerative braking during foot strike, is reclaiming energy in ways that were previously theoretical. Every step isn't just consuming power, it's partially recharging the system, which fundamentally changes how long these robots can operate in the real world. A humanoid robot that can run at 7 miles per hour for meaningful durations without cooking itself is no longer a lab curiosity, it's a platform. What makes this moment unsettling for competitors is that Tesla didn't achieve this by inventing exotic materials or relying on prohibitively expensive components. The Gen 3 bot is built with manufacturability in mind, using scalable production techniques and supply chains Tesla already controls. That means this level of performance isn't locked behind a prototype curtain. It's something that can be replicated, refined, and eventually mapped. When Musk reportedly said that the run made him rethink timelines, it wasn't hype. It was a recognition that the cost curve and the performance curve just intersected sooner than expected. Robotics history is full of impressive demos that never escaped the lab because they couldn't scale. This one feels different. The psychological impact of seeing a humanoid robot run this way shouldn't be underestimated. Humans are wired to judge intelligence and capability through motion, and running is one of the most demanding expressions of coordinated movement we know. Walking robots are impressive, jumping robots are flashy, but running triggers a deeper instinctual response because it signals readiness, urgency, and autonomy. The Tesla bot Gen 3 didn't just run, it ran with purpose. And that's why the clip spread so fast among engineers, investors, and skeptics alike. Even critics who have dismissed Tesla's robotics ambitions as a distraction from its automotive business found themselves pausing, replaying the footage, and quietly recalibrating their arguments. Behind the scenes, the run forced Tesla's internal teams to confront new questions. If the bot can move this fast and this smoothly, what tasks does that unlock sooner than planned?